need to begin with the soil, as this is where the successful production of every crop begins. Analysis is the key to taking a photograph in time and assessing nutrient status. A soil analysis takes the guesswork out of formulating a nutrition programme for both our crops and feeding our livestock, as reverting to doing it the way we've always done can actually cost more money than is often required. When was the last time you carried out a soil analysis? I suggest 3 years for cropping and 4 for grazing. To match soil analysis reports, I complement this with a slurry analysis, allowing me to work out a more comprehensive fertiliser programme for silage production. RB209 is a great starting point when looking at nutrient values, but it must be pointed out that these values printed are based on averages. It stands to sense, if you're feeding a high-yielding dairy cow on your farm, then your slurry will contain much more nutrients than the slurry produced on a suckler cow enterprise, and therefore it's important to take these values into consideration. Currently, using a rough calculation from RB209, 3,000 gallons of 6% dry matter dairy cow slurry applied with a conventional tanker during the months of February to April will supply approximately 28 units of nitrogen at 40% availability, 16 units of phosphate at 50% availability, and around 60 units of potassium at 90% availability. It's therefore essential to plan bagged fertiliser applications around silage yield targets based on these estimates. The main points that I look for on a soil analysis are: number 1, pH, number 2, phosphate, number 3, potassium, otherwise known as K, and 4, magnesium. pH is a measurement of either acidity or alkalinity in the soil. Ideally, we should be looking for a pH above 6, with 6.5 being ideal. This is extremely important for efficient nutrient uptake. Here's a chart which I've printed off showing nutrient availability at various different soil pHs. If we take an example soil with a pH of 5.5, which is not uncommon, the table clearly shows a nutrient uptake of 77% for nitrogen, 48% for phosphate, and 77% for potassium. Using a quick example of nitrogen fertiliser for silage land at £250 per tonne, this would mean that £57.50 of that tonne would be wasted. Lime is approximately £24 per tonne, which still makes it the cheapest fertiliser money can buy in terms of pH correction. Always ask for the NV of your lime and purchase a good quality limestone from a trusted supplier. Avoid dolomitic limestone, which contains magnesium if it's not required. I like to apply a good base coat of agricultural limestone when I'm reseeding and or cropping, and then maintain that pH level with maintenance dressings of granular lime via the fertiliser spreader. This reduces compaction. 50 kilos of granular product should increase pH by 0.1. Remember to check magnesium levels in granular lime, as if soil levels are high, you don't need any more.